Welcome to series of database management system video lectures. Today we will be discussing about unit 4, that is topic 4.2, integrity constraints over the relations. In the previous video we have discussed about what a relation is and what are the various terminology related to the relations. Now let us see what is a constraint. Constraint is nothing but a rule which is going to be specified on one particular data element. So this helps us to perform or to achieve data integrity with respect to the data which is stored in the database. We don't want it to violate any rules which are being specified upon the data. As we deal with huge amounts of data in the databases, we need to get a reliable data. The database system should be maintained in a consistency manner, and we should be able to have a data integrity. So to achieve these set of things, we have the constraints, and these constraints have been subclassified into three categories. The first one is domain constraints, second is key constraints, third is integrity constraint. Let us get a deep dive into each and every type of the constraint. The first one is domain constraint. So in domain constraint, from the term itself, we can understand that domain is related to one particular area. So before this domain constraints, these constraints are subclassified into other two categories, that is column level constraints and then table level constraints. Domain constraints can be taken as column level constraints. So which indicates that we are going to define a particular domain for an attribute. Now let us look at here. I wanted to create a table with the name student 5. Here I am considering three different attributes. One is student ID, which is of type integer, student name, which is of varchar data type, age, which is of type integer. So now we have created a table with the name student 5. Now let me get the schema of this particular table. So we need to write the command describe a table name, right? So this is the schema or the structure of that particular table that we have created. Now let us look at the detailed information about this table. So we have the data elements which are displayed in a tabular format. The first one is field, that is the column name. The second one is type, the data type according to which the data should be supplied by the user. And the next one is null constraint, key constraint, default constraint, and then extra constraint. So these are the set of attributes that we are going to define at the time of creation of the table. Now for student ID, let me access to this particular table. Yeah. Student file, let me get the structure of this student table. Now, if I'm trying to insert into student file values, now what is the first one? Student ID, which is a type integer. I cannot give the value to this particular integer beyond the range. Now let us say that I wanted to give this number as a student ID and the name is of a varchar data type. So I have passed this, and then age. Age also, if we just go with the first one. Now, the first record is inserted. Let me take a more larger value than this. Okay, now look at here. For student ID attribute, as I have given a very large value, it is not going to accept. So now, at the time of creation of the data element itself, we are specifying the data type. That means this student ID is of domain integer. And I have a particular range wherein I can select the values or supply the values. You cannot give beyond that particular range. So when you are trying to give the digits more than 10 digits, it is not going to accept because the domain type of integer will not accept that value. So that is about column level constraints or domain constraints. Now, let us look at the next one, that is key constraint. Yeah, when it comes to table level constraints, that can be discussed as part of a key constraints or integrity constraints. Okay, so let us look at a key constraint. Now, key constraints are going to be defined to retrieve every individual record uniquely. Now, what can be that best thing, best attribute that can be taken to retrieve the record uniquely? So here we have created a table with the name student with the following attributes, that is ID, name, address, and course. Now, I wanted to retrieve the records from the student table. If I go with course, there is a possibility of multiple number of students enrolling into same course. So I will not be able to retrieve that. Multiple number of students can be residing to one particular location. So even that cannot be taken as the correct attribute. And third one is within a class, you can find at least more than one student with the same name. So even this name attribute cannot be taken to retrieve the record. So finally, we have ID number, which is going to be allotted differently for all the set of students. So based upon this ID attribute, I will be able to retrieve every individual student's record, right? So we can say that ID is a key constraint here. ID can be taken as a key attribute through which you will be able to retrieve a record uniquely. Okay. Now let us look at the other table, person table. Here you have person name, date of birth, passport number, license number, and social security number. So when we consider these set of attributes, you can find employee or a person with the same name. So I cannot refer this to be a key attribute. Date of birth, there can be a possibility that people with the same date of birth. So even you cannot select this as a key attribute. Passport number can sometimes be passport number can be different, right? And the license number, there is a possibility of having same, so you cannot prefer. Social security number can be taken as a unique one, right? So from this, I can say that 1, 2, and 3 can be used as a key attribute. Any one of it can be taken as a key attribute. Okay. So the first one is key constraints helps us to retrieve the record uniquely. So that is our main motto. We have various types of key constraints. The first one is primary key. Second is candidate key. Third is super key. fourth is foreign key, fifth is alternate key, sixth is composite key, and finally we have seventh one, that is artificial key. So let us look at these types of constraints. So the first one is primary key constraint. How can we say that an attribute can be taken as a primary key? So primary key, before we discuss about this primary key, let me take you to integrity constraints. So here we have to maintain integrity in the database. We need to follow the following types of constraints, that is entity integrity constraint and referential integrity constraint. As part of entity integrity constraint, we have this helps us to perform the operation in such a way that you will be able to retrieve a row or a record in a unique manner. Okay, so let us, the first entity integrity constraint is not null constraint. So which indicates that if, let us say that I have created a table, let me go, not null constraint. Now I have already created a table student 5. Let me drop student 5, create table, table name is student 5. I wanted to create a student ID which is of type integer, student name which is of varchar data type, varchar of length 10 characters, and age which is of type integer. Okay. So now when you're trying to create a table in this manner, it allows you even null values as well. So now we have created a table. Let me insert the data into it, insert into student 5 values. So now student ID number is 10 and name, let me take it as J, and age is 23. Okay. Now here for student ID, if I don't pass any value, let it be null. Even then the data is going to be inserted. Student 5. Look at here. So now can we find a student without an ID number? No. So when you don't apply the constraint, we are going to get this kind of inconsistency of data elements, right? So that's the reason we should apply a rule. We should state a rule in such a way that it should not take this kind of data elements. So let me change that. We have two alternatives. One is at the time of creation of the table itself, we can set up the not null constraint, or by using alter command also, we will be able to modify. So now let me show you at the time of creation, create table, table name is student 6. Let me go with the same thing, student ID of integer, name which is of type varchar of 10, and then age which is of type int. So now I wanted to apply not null constraints to the student ID. Okay. So now if we set up student 6 is already existing. So let me define it as student 7. Yeah. Now the table has been created. Let me get the schema of it. Student 7, right. So now look at the structure of the student table. For student ID roll number, not null constraint, it is not going to accept any null values. That's the reason it has been changed to no. Okay. So now when let us repeat the same thing for inserting data here. That is student 7. Okay, let me insert this kind of values. See, student ID attribute is not going to accept any null values as we have set up a not null constraint there. This is at the time of insertion of the data. At the time of creation of the data, we have set up it. And the other mechanism is while going with alter command. Okay, so now for the next entity integrity constraint is unique constraint. So now this constraint can be applicable when you wanted to have only unique values. We are not going to accept any duplicate values. Let us look at it. So already we have created table, that is student 5. So let me display the content. I'm sorry. Yeah. So now I have already created a table of a student 5 with null, right? So let me insert some more data, insert into student 5 values. Now here I need to supply roll number 1 and name is Vani and age is 32. Okay. I have inserted one record. Let me print that record. Fine. Now let me add one more record. So here, let me give the same roll number and the name is Ravi and the age is 40. Okay. Fine. So again, we have inserted the records and look at here. Can we have a student with roll number 1? Yes. No. So we are losing the integrity of the data here, right? So duplicate values are being accepted because we did not apply any constraint here. Now let me modify that. Let me add a constraint that is unique constraint. So using alter command, alter table, table name is student 5, modify the column name that is SID, which is of type int domain data type. And I want this to be unique. Okay. So first thing is that we are going to apply a unique constraint, but then as we have already come across with two records with the same ID numbers, that's the reason it is not going to perform that. So we need to either change that. So let me change that value by using update. Update. If we do update, also fine. Update table. Table name is student 5. Set SID equals to whom I wanted to modify. I need to use a where clause where name equals 1. To this particular number, I wanted to change that. to this particular name, I wanted to modify that. Now let me display the content of the table. Yes. Now if I apply that, let me describe the table first. Yes. Now let me apply the constraint, that is unique constraints. Now the constraint is applied. Now let me display the schema of the table. Now you will find a key. Earlier the key attribute was empty. Now I have applied unique constraint. That's the reason it is reflecting against to the SID attributes, right? Moving on to the next one, that is primary key attribute. This is one of the key attributes. This can be useful to identify or access to one particular record uniquely. So primary key is a combination of both. It is a combination of both not null as well as a unique constraint. Okay. So let us see how do we apply this. Already we have created this table. Let me drop that table. Drop student 5. Drop table name. So now I have totally removed that table. Now let me create the same table. Student 5. Create a table student 5. Now student ID, which is of type int. Either I can specify to this particular attribute here itself, that is primary key. Okay. And the second one is name, which is of type varchar of length 10, and then age, which is of type int. Okay. So this is how we can define a primary key constraint upon the student ID roll number. This helps us to retrieve a record uniquely from the given set of data items, right? That is the first way, or we can even use the alter command as well. So now let me insert the data into it. Let me describe the schema of it. Student 5. Now look at here. When you have applying a key constraint, it will reflect in this column. Now, when it is a primary key, it absolutely will not take null values there. So that's the reason it is no there. Okay. Now, let me insert the data into this table. Insert into, that is student 5. Student 5 values. The first one is, let me give it as 1. Next is Hari with the age 20. Okay. Now I have inserted a record. Let me insert another record with the same ID number with the name as Harini with age 21. Let us see. Now, duplicate values are not going to be accepted because we have already applied a primary key constraint. So we cannot violate the rule which is being specified by us. Okay. So this is how we are going to maintain unique values throughout the table. So we can refer this as a table level constraint. Now let us look at the next type of constraint, that is check constraint. Now let me drop this table. Drop table. Student 5. Okay. Now we have removed. Create table. Student 5. Let us go with the same attributes. Int name of varchar of length 10 characters, age which is of type int. Now this is how we are going to create a table. Fine, we have done. Now I wanted to apply check constraint here. Okay. Now while applying check constraint, I need to check whether check SID value. Okay. So let me apply this constraint. So it is not going to accept a value lesser than 0. Okay. So let me insert the record into this table. If I insert like this, fine, it accepts. Let me repeat it, SID number as -1. See. So the rule, the constraint which we have applied here is it should not accept any value for student ID lesser than 0. So that's the reason it is stopping me to insert that record. Okay. So this is about check constraint. Now the next one is default constraint. Now let me drop this table. Drop table, student 5. Now let me create table name, that is student ID. Now instead of this check constraint, let me have default value to be, if none of the value is being provided, let me take it as 100. Okay. So now let us insert the data here. Let us print. So now when I have provided this values with a null, then exclusively it goes with null values. Now let me change this. Student 5. Now here, student ID, I am not willing to pass any value, only the name. So ampersand name, comma, age value I'm supposed to pass. Okay. Values. Now I'm not going to give the first value here, just these two values. So let us create a table. Student 7, student age, which is student ID, which is of type integer. Now if the user has not provided any value, then I want the default value to be taken as 100 for this. And then name, which is of type varchar of length 10, and then age, which is of type int. Okay. So now using this, you will be able to create the table in such a way that if the user has not provided the value, then it substitutes with 100 value. Okay. Now moving on to the last type of constraint, that is foreign key constraint. This is going to be used. Let us look at this foreign key. Look at this table, employee table, which contains the following attributes, that is employee ID, employee name, passport number, license number, social security number. Till this, all these set of attributes are belonging to employee table. Okay. Now we are creating another table, that is department table. Okay. So in this department table, we will have department ID, which is a key attribute to uniquely retrieve the records. Similarly, here we have employee ID as the key attribute. Now, department ID and department name are the attributes belonging to department table. Now, I need to have a link between these two tables, how it can be formed. So we need to identify the key attribute from this table and have the same data even in this table. Okay. So based upon that data values, you will be able to retrieve the records. So we call it as a foreign key. Right? Already we have discussed about how to create a single table having a primary key. But now when we wanted to deal with a multiple number of tables, as we cannot maintain all the data items together in a single table, we will create multiple number of tables having link between these tables, creating with a foreign key constraint. Let us create this foreign key constraint. Now let us create a foreign key constraint using this table. So let me create a table employee age, which is of with attributes employee number, name, job, department number, which should be created in department table. And let me have a primary key constraint upon employee number. And then I wanted to apply a foreign key constraint upon department number, which is going to be referencing to the department table of department number. Right? Now this table is created. Let us create table department 8. Okay. Here, department number. Make sure that both of the data types should be of same, which is of integer of 2. Okay. And then department name, which is of type of varchar of 10. Right? And then we can even have, location, which is of type of varchar of 10 characters. And now let me apply a primary key constraints upon department number. Okay. So now we have created an employee table and department table, and we have created a relationship like this. Okay. Now while inserting the data also, we should be careful. Let us try to insert the data of employee 8, or first you can insert the values and department. Insert into a DEPT 8. Okay. The department number, let us say that it's 12, and the department name is of a sales department. Let it be enclosed by single quotation. And then location, I wanted to have this to be at 40. So we have completed foreign key constraint. Moving on to the next one, that is a candidate key. So candidate key is another type of key constraint wherein the attributes can be taken as other than primary key attributes. Now look at this particular example. In employee table, we have employee ID, which can definitely be taken as a primary key attribute, right? Apart from that primary key attribute, do we find any attributes which can also be helpful for us to pick a record in a unique manner? Yes, we could find these a set of numerical values which helps us to identify the records, right? So those set of things can be taken as a candidate key, whether it is a single social security number or a license number or a passport number. Any one of it can be taken as a candidate key. Okay. Now the next type of key is a super key. Super key is going to be a superset of all the candidate keys. Okay. So super key can be written as a combination of employee ID, employee name, passport number, and social security number. Now, from this set of attributes only, we will be able to have a candidate key. Candidate key can be taken as just the passport number or social security number, or third one is combination of a passport as well as a social security number. Right? I mean, super key is going to be taken as a group of attributes, which is going to be a superset, and you can derive a subset of candidate keys. Okay. Moving on to the next one. Yeah, foreign key we have completed. Candidate key is again a combination of any set of key attributes that we have taken. For the employee table, we have employee ID and then PAN number. Employee ID can definitely be taken as a primary key attribute, and PAN number can be taken as an alternative key. Apart from the primary key attribute, you can even go with the PAN number as an alternate key, and both together can be taken as a candidate key. Okay, when we don't have a choice of dealing with the other set of attributes, then we can have a candidate key. Then composite key is nothing but combination of more than one attribute together. So here employee ID itself is taken as a primary key attribute. Project ID can also be taken as a key attribute, but combination of both the things together like this employee ID and then project ID, wherein key that is going to be used more than one attribute is called as a composite key. And finally, we have artificial keys. Artificial keys are not going to be taken as the special attribute as part of the table, right? Which do not construct that important information as part of the table, right? So row ID can also be sometimes taken as an important criteria to refer to the records which can retrieve the data in a unique manner. Apart from all the other types of keys, if you don't have any combination of key attributes, then we can go with the artificial key. Okay. So these are the types of integrity constraints. So referential integrity constraint here is going to be taken as a foreign key constraint that we have already discussed. Okay, primary, default, null, which we have already completed. So with this key constraints, implementing key constraints upon relations is completed.